This meeting is being recorded.
Problem number 29 from chapter 2 asks us to draw the resonance hybrid for each of these following structures. So we're given A through D here, and let's walk through how we can determine this resonance hybrid. So we'll have to draw all the possible resonance structures and then kind of take an average of those structures. So we see in structure A here that these bonds move either clockwise or counterclockwise to create the second resonance structure here. So we see these alternating double and single bonds that have switched places in this benzene ring. But overall, we have no formal charges, so what we see is drawn down here, and there's just a kind of dotted line inside of our hexagon, and that serves to represent the resonance hybrid for benzene. Then we have in structure B here, we see with our resonance structure that we have moved this lone pair, and that causes that pi bond to shift, and then we end up with a lone pair on the other side in our resonance structure. So the average here would show a single bond, and then this dotted line to represent a double bond across both sides. And also the charge, the -1 formal charge, will be evenly distributed as well. So it's kind of an average of the charge as well. Then we have resonance structure C. The most significant form here is the structure that's given. That's because all of the atoms have a full octet, so that's why that's most significant. When we see here, after movement of some electrons, we move the pi bond from that carbonyl up to the oxygen, and we create that carbocation here. So that does not have a full octet. It's electron deficient, has a positive charge. So what we see over here in our resonance hybrid is that both a slight or a partial positive charge on the carbon, and then we also have a partial positive charge on the oxygen. Last, we have structure D over here on the upper right, and notice our first structure, and we have our movement of electrons here, and we have, so these guys will move over here, and these will move down here. And then we have our second resonance structure. So what you may notice is that the formal charge on the nitrogen, that remains between the two structures, but the -1 formal charge on the oxygen changes from one side to the other. So what we see is our resonance hybrid up here with the nitrogen having a +1 formal charge and then a partial negative charge on both of the oxygens. And then we see that that 1.5 bond, if you will, between both sides of the molecule.